All right, welcome to the 6-2 lecture. And so in this lecture, he's making sure that you understand some basic fundamentals of arithmetic that are very necessary for trig. So there's a key word in all of this that is being used, and that is finding the exact value. We do not want it to be a decimal number that goes on forever. We want it to be a simple number like 1/2. That'll be a very common output. So will root 3 over 2. So will root 2 over 2. And so just like in your trigonometry days, you're probably already familiar with these things, but we're going to go over it one more time. But even in your algebra days, you know you can't leave a radical on the bottom, and so we need to rationalize and come up with answers like that. So the common answers are 1/2, root 3 over 2, root 2 over 2. There's also a 1 that can come out, a 0 that can come out, and an undefined. Those are our typical answers, and they're either positive or negative. Now, granted, 0 and undefined can't be either positive or negative, so they'll just be that. But you'll get plus or minus 1s and 1/2s and plus or minus 3/2 and plus or minus root 2's over 2 all the time. And what really it depends on is what's the reference angle and where are we, which quadrant are we in. And so what he does first, let me get rid of this middle writing here. What he does first is just remind you of some basic principles, super basic, that if you divide by 0, the result is undefined. We've known about that since our pre-algebra days, since we were dealing with slope. And in fact, trigonometry has a lot to do with slopes, especially the tangent. If you have something, sometimes you're going to take a 1 and divide by 1/2, depending upon how you were taught. I would highly recommend memorizing the angles. So for example, I should be able to say sine of pi over 6, and you should be immediately able to say 1/2. Just like you can say 3 times 3. If I say 3 times 3, you're automatically thinking 9. We need you to be at a point where sine of pi over 6 is 1/2. Sine of pi over 3, root 3 over 2. Sine of pi over 4, root 2 over 2. That type of thing is what we need. Absent of that, you'll be having to do these fractions, right? Because you'll have to memorize triangles, which he has down below. And so if you have 1 divided by 1/2, like we do here in example 2, you know what to do. From your arithmetic days, you multiply by the reciprocal, and you come up with the number 2. So when I was mentioning that numbers like 1/2, root 3 over 2, and root 2 over 2 were the only ones that you'll come up with, I was mistaken in a way. I was only considering sine, cosine, and tangent. If I look at the opposites of those, cosecant, secant, and cotangent, then we could have the flips of all of these, or 2 and 2 root 3 over 3, and root 2 will also be there. And so you'll see all of these work out. Let's look at example 3. Example 3 wants us to take 1 and divide it by root 2 over 2. So we know what to do. We're going to multiply the numerator by the reciprocal of the denominator. And so when we do that, we get 2 over root 2. Now, we cannot leave it like that. The reason why we can't leave it like that is because there's a square root on the bottom, and we know ever since you learned it back in, well, where would it have been? Probably intermediate algebra. That first time you looked at it, you cannot have a square root in the bottom. And so we rationalize it, like you remember, by multiplying by root 2 over 2 and root 2 to top and bottom, and we just end up getting root 2 out, right? One of my options right up here. The better ways to handle that. So if you've learned something better, if you have these already memorized from your trigonometry standpoint or have different ways of figuring it out, please don't morph yourself into a new way. If you have something that's consistent, use that. So again, here we have 1 over root 3 over 2. We're going to flip that. Multiply by the reciprocal. Again, we have a square root in the bottom that we can't handle, so we multiply by that square root to the top and bottom, and we get 2 root 3 over 3 in that regard. Sorry, didn't mean to jump that low. I think I touched off to the side here. So they would get a nice example there of 2 root 3 over 3. If we go look at example 5, sometimes we'll have to do this. Take a 1/2 and divide it by root 3 over 2. And that's because tangent is related to sine over cosine, and cotangent is related to cosine over sine. And so we'll have these possible divisions depending upon how you memorize, how that was instructed to you in your previous course. So again, nothing earth-shattering here. If we have 1/2 divided by root 3 over 2 like we do here in example 5, we're going to multiply by the reciprocal of that, which is 2 over root 3, and we get 1 over root 3. Can't leave it like that, so we multiply top and bottom by root 3, and we get root 3 over 3. Then over here, we have root 3 over 2 divided by 1/2. It's the 1/2 that gets flipped, always the bottom one. 2 over 1, just basic arithmetic. The 2's cancel out, and you're just left with mistake, right? I hope that you saw that. So here we found another mistake within the notes. If those 2's cancel out, you're not left with root 3 over 2. That would be very confusing as you read that. What are you left with? You're left with just simply root 3. Certainly not root 3 over 2. If we got root 3 over 2 back out, we must have been dividing by 1. And we weren't. We were dividing by 1/2. So what's happening here? Well, he's giving you the standard right triangle approach. And what we want to remind you of, all of this should be a reminder. If it's not, you'll have to spend a lot of time studying trig. It was never the intention of this course, but let me know. I can help and give you directions. But if we look at the standard pi over 6 reference angle, or 30 degrees, this is the standard triangle. So you'll want to memorize some of these relationships. So what he has in here, just to make sure you're aware of it, he has a very specific number for the hypotenuse, number 1. And because of that, we can say that if r is equal to 1, so r is the distance always from the center all the way out, right? So this is what r is. R is from the origin out to the terminal point of along an angle, right? You could pick any point like that, but he's picking r. R could be like 5 and be way out here, but he's picking r to be only 1 out. And when he does that, if you have 30 degrees, then you have a 1/2 rise and a 3/2 run, a y height of 1/2 and a x run of root 3 over 2. Well, we want you to know if r is equal to 1, then sine theta corresponds to y. And if you were taught the unit circle approach, you already know this. Cosine theta corresponds to x. So, for example, if we just look at this first triangle right here, we already know that sine of, and you can either say 30 degrees or pi over 6. I'll say pi over 6. You know it's equal to the y heights, or 1/2. What's the cosine of pi over 6? It is root 3 over 2. Now, tangent of pi over 6, they're saying is y over x. And this is why he's having you do that relationship there. So that one's a little bit hard to see because I'm sandwiching in there. So I'm going to erase a little bit here. And so sine and cosine are just right on the angle. But if we want to go look at doing something like, and I'll put it in red. Sorry, let me switch to red. Tangent. If I go look at tangent related to this triangle, tangent of pi over 6 is equal to y over x. And that's what it would look like. So now you can see why he had the examples above. If this is what you're limited to, only a right triangle approach with the number 1 as the hypotenuse. And again, he's just going to bring up something to jog your memory. Then we have to just follow those instructions, right? Or the earlier examples that we'd multiply by the reciprocal. The 2's would cancel out. We'd be left with 1 over root 3. But we do have the presence of mind to realize that, oh, I can't leave that there. I got to multiply by, and I'll do it in a different color, root 3 over root 3. I'm introducing that so that I can rationalize the denominator and I get root 3 over 3, which is the tangent of pi over 6. And so this is, again, just meant to jog your memory. And so we have all of those guys right there for you. So here's 45 degrees. Both sides are 45 degrees is exactly right in between 90 degrees. So you can remember that the sides are the same and both root 2 over 2. And then with the other one here, let me switch this to the bottom. Oh, yeah, I will pull it down to the side even better. So that is a root 3 over 2 as a y height and a 1/2. So notice the 30 degrees is exactly the flip of the 60 degrees, right? These two triangles are definitely related. Why? Because if this is 60 degrees, then up here is 30 degrees. And if this is 30 degrees down here, then this is 60 degrees up here. And you can see that opposite the 60 degrees, the y height is root 3 over 2. And so he's just trying to get you to memorize those as well. And then again, he's reminded you of radians and stuff, but we should be well familiar with that. So let's take a look at this one right here. Sine of 5 pi over 3. He's trying to step you into a way to handle this. What I'd like to recommend is, well, actually, I'll just go with his. So if you're having sine of 5 pi over 3, Professor Eitel's recommendation, and again, if you have a different way of doing it from your previous class, please do so. His recommendation is to say, okay, let's find the reference angle. So 5 pi over 3, I'm going to relate it to either 3 pi over 3 or 6 pi over 3. Those are the two things I'm considering. I'm realizing that it's really close to 6 pi over 3. So just like in our last video, the reference angle is, and I'll put the reference angle in a different color. The reference angle is pi over 3. That's what he's referring to here, or 60 degrees. So ideally you have the triangle memorized or the result memorized, right? So he's putting the triangle here. Now we're supposed to find the sine, and the sine of pi over 3 is related to the y. The y height is root 3 over 2. So now we know that sine of 5 pi over 3 is going to be root 3 over 2 maybe. What he's reminding you of here is that all students take calculus. All students take calculus. So where are we? We know that we are in the fourth quadrant, right? We already figured that out. Find the quadrant the angle is in. And so he's having us go through degrees, which is fine. Not sure why, but he's having us go through degrees because I think radians is a lot easier. Because it was very easy for us to see in a radian measure that we were only pi over 3 off of 6 pi over 3. But regardless, you could change it to degrees if that's what you're most comfortable in. 300 degrees is definitely in the fourth quadrant. Well, if we're in the fourth quadrant, then our sine is negative. I'll put it this way. Our sine's negative. Every sine in the fourth quadrant is negative. So when you have the sine of 5 pi over 3, you know it's root 3 over 2. But because it's in the fourth quadrant, again, he has a mistake. Sine of 5 pi over 3, yeah, I don't think there's a fifth step. Sorry, I was looking to see if there was a fifth step in there. There's not. All students take calculus. Sine is positive in the first quadrant and in the second quadrant. So in the fourth quadrant, it's actually negative. So again, I'm grateful that we're going through these videos. You can see that here. 11 pi over 6 is in the fourth quadrant as well. Cosecant's related to sine, and so you get a negative. But let's step through that example as well. And we'll just read what he has. So we're looking for cosecant of 11 pi over 6 in example 2. I'll just make it really big there. So as we look for cosecant of 11 pi over 6, he's wanting us to find the reference angle. So again, 11 pi over 6. Is it closer to 6 pi over 6 or 12 pi over 6? Well, it's really close to 12 pi over 6. How far is it back? It's back a reference angle of pi over 6. So cosecant is pi over 6. Now what is cosecant? Cosecant's the flip of sine. Let's see what he has up here. Does he have cosecant up here? He does. It is, I did it again. It is, sorry about that. It is 1 over y. It's the flip of the sign. So 1 over y. So let's come back down here. Sorry, if I don't use 2 fingers, it draws on it. So it is the flip. And so that's what he has here. Cosecant of pi over 6 is 1 over y. Well, y is 1/2. And so again, he has a mistake. He has something weird here. Where is all this coming from? Could be the question. That's not what we need. We need 1 over y. Y was 1/2. So big mistakes in here. So grateful that we're going through. None of that makes sense because that's more of an x over y situation. But we have 1 over y because we're cosecant. So it's 1 over 1/2 because if you look up here, our y is 1/2. Well, you know what 1 divided by 1/2 is. It's 2. Right? Because we just flip that 1/2 up and we get 2 from our first examples. So then he's going to figure out what quadrant it is. You and I already know it's in quadrant 4, but if it does help you to know that the angle measurement is 330 and it's in the 4th quadrant, that's great. So if we go to the 4th quadrant, all students take calculus. Okay, cosecant is the flip of sine because it's 1 over y, so it's going to be negative, so he has that right. But cosecant of 11 pi over 6 is equal to -2. That's the right answer coming out, not the negative root 2 over 2. That is strange. Root 2 over 2 is related to a pi over 4 angle, so it's a little bit messed up there. So let's go to example 3. As we look at example 3, I can make it big here. Cosine of 3 pi over 4. So my first question is, where the heck are we? So we draw our axis. Let me get a better pen there. We draw our axis and we go find 3 pi over 4. Well, it's really close to 4 pi over 4. Because what's 4 pi over 4? It's pi. And so we're almost there, but we're not quite there. How far are we back? We're back a reference angle of pi over 4. So we're in the 2nd quadrant. All students, we already know that the result is negative. We can take that into account already. We have a 2nd quadrant angle, which we know right away. The result is negative. The reference angle is pi over 4. Here's the pi over 4 reference angle. Cosine corresponds technically to x. And so you're already done. That's how fast it should be, root 2 over 2. Again, we'd love for you to have it memorized that's way. So if we follow Joe's or Professor Eitel's definition, he's going to say, hey, cosine is related to x, which is root 2 over 2. It's in the 2nd quadrant because it's 135 degrees. And so it's going to take a negative sign. You should already be really fast at this, but you will get really fast at it. Secant. If you didn't know already, secant's the flip of cosine. Now, what's Joe's wording say? It's 1 over x, right? Remember, cosine was x, so this is just the flip of it. 5 pi over 4, really close to 4 pi over 4. Where is it? It's pi over 4 beyond. So my reference angle is pi over 4. That's the whole point of the reference angle. So you know that it's related to pi over 4. Now remember, all students take calculus. Everything's positive in the 1st quadrant. Students, only sine's positive in the 2nd quadrant. Everything else is negative. Sine in its flip, cosecant. Tangent. Only tangent and cotangent are positive in quadrant 4. Cosine. Only cosine and secant are positive in quadrant 4. I think I may have said tangent was in quadrant 4. It's 3, as you can see. So we know that we're in quadrant 3. We already know secant's related to cosine or x, or you could also see that, I have a negative x value. So it's going to be negative, and it's going to be root 2 over 2. Actually, the flip of that, right? 1 over root 2 over 2. So it's 1 over root 2 over 2. So what's that? Well, 1 divided by root 2 over 2 is 1 times 2 over root 2, which is 2 over root 2. We have to then rationalize the denominator and get 2 root 2 over 2. And we just get a nice root 2 out of that. And so that's what you'll watch happen down here. It's 1 over root 2 over 2, which he says is root 2, like we just figured out above. He mentions that it's in the third quadrant, so we're going to find the appropriate sign, which is negative, and we get that negative root 2 answer out. Pretty awesome. Okay, so pretty big lecture. Let's see what other things we can do as we go through here. Let's take a look at example 5 here. Tangent of 7 pi over 6. And we'll just read through his. 7 pi over 6 is related to pi over 6, right? What quadrant's it in? Well, it's just beyond 6 pi over 6, so it's right here. So it's in the third quadrant. All students take calculus, so we already know the result is positive, right? But he's having us say, okay, it's a pi over 6 reference angle. I agree, right? You agree as well. It's tangent. Tangent is y over x, right? It's written down here, or 1/2 divided by root 3 over 2. When you flip and multiply and rationalize the denominator, you get root 3 over 3. Let's watch that happen really quick. Right? Apologize, I needed to flip that. So it's 1/2 divided by root 3 over 2, or times 2 over root 3. These 2's cancel. You're left with 1 over root 3, and then you have to rationalize. You'll get very quick at this and just start to recognize where it is. But that's how you got root 3 over 3. Then you're going to recognize that you're in the third quadrant like we already saw. Tangent's positive in that quadrant, and we get root 3 over 3. Something similar happening here, right? Here we're doing cotangent. Okay, 7 pi over 4. Reference angle is a pi over 4 reference angle. Pretty easy to see that with the 4 on the bottom. Then we'll look at cotangent, and you can look above or have memorized that it's x over y. It's the reverse of tangent. So it's root 2 over 2 divided by root 2 over 2, which is 1. Okay, so then we have to figure out what quadrant we are in. 7 pi over 4 is in the fourth quadrant. You can see that either through degrees or through the radians. And because of that, because in the fourth quadrant, tangent, well, let me just say it this way. The only thing positive is cosine, and it's flipped secant. We are going to be negative if we're cotangent, and that's where he gets the -1. A huge part of your next class is having these results all memorized, or be able to figure them out pretty quickly like we're doing. If you don't know trig and calculus, and they don't teach it there, you get it through your trigonometry course, which you've already taken, and we reinforce it here. It's not reinforced in calculus. They just use it, and there's no section for it. It just comes up within sections, just to warn you. Cotangent of -5 pi over 4. Okay, so again, the reference angle is going to be a pi over 4 reference angle, right? We can get that from the 4. Cotangent is x over y, so we're going to get a 1 out again. And then we have to figure out what quadrant we're in. So if we're -5 pi over 4, he's claiming that we're going to be in the second quadrant because it's -225, and I agree. One way to figure that out through radians is -5 pi over 4 would be going this way. This is -4 pi over 4. And so -5 pi over 4 would be 1 more pi over 4. There's your reference angle, and there's -5 pi over 4 in the second quadrant. We're dealing with only sine and cosecant being positive there, so he should choose the negative sign, which he does. Over here, in example 8, 15 pi over 4. Again, because the 4 on the bottom, we're going to have a pi over 4 reference angle. Tangent is y over x, and for a 45-degree angle, that's a root 2 over 2 divided by itself, so we get another 1 out. So the only question is, we get this 1 pretty fast. The only question is where are we? Is this 1 going to be positive or negative? Let's see where we are. So he goes through and figures out where he's at 315 degrees and claiming that he's in the fourth quadrant. I agree with that. So if I were to figure it out, I would say 15 pi over 4 is really close to 16 pi over 4. If you look at 16 pi over 4, that's 4 pi. That's right here. 2 pi's here, 4 pi's here, 6 pi's here. We're not quite there yet. Of course we're in the fourth quadrant. In the fourth quadrant, only cosine is positive, but we're dealing with tangent, so he should choose a negative sign, and he does. This is what this whole assignment is just having you remember what these special angles are. So we'll do this next one, and then we'll skip 10. You can read that on your own and see if there's anything new, because it's pretty much the same. You can see a 3 underneath here. That's how he knows it's a pi over 3 reference angle. Got to be a little bit careful about that, but they're always, if they ask you to find the exact value, they're always choosing them very specifically. So a pi over 3 is a 60-degree reference angle, and so it is a root 3 over 2 and a 1/2, a root 3 over 2 in the y, and a 1/2. So if it's 60 degrees, it's big, and so the bigger number goes up on the y-axis. I don't know how if you don't have that memorized already, I can help you out individually with ways to memorize that, but there's one. Looking for patterns like that. You know that cosine's related to x, and x is 1/2. So we would be done if the angle was just pi over 3, but it wasn't. All we have to do is we know our answer right now. The answer for cosine of negative 11 pi over 3 is absolutely going to involve a 1/2. The question is it positive 1/2 or negative 1/2? And so that's where we go and investigate where are we. So let's look at his investigation. He's saying that we're going to be right smack dab in the first quadrant, and that's exactly what I think as well. Now, why do I think that? Because a negative 11 pi over 3 is really close to negative 12 pi over 3, which is negative 4 pi. Well, where's negative 4 pi? It is, here's negative 2 pi, here's negative 4 pi. It's right here. It's on that positive x-axis. Remember, we saw in that last lecture notes that the 0 includes all the even multiples of pi, whether they're positive or negative, and we're backed up off of that. So of course we didn't quite get to negative 12 pi over 3. We are right here, a distance of pi over 3 back. He's absolutely right. It's in the first quadrant where every single thing is positive, so therefore he's choosing positive 1/2. Okay, so what he does next is he goes to the quadrantal angles. And so let's see what he's going to do here. If you have sine of pi over 2, ideally you have that memorized as what that is. But remember, sine theta corresponded to y. So picture that. You know where pi over 2 is. It's right here. And so how far away is that? That's just 1 away. So sine of pi over 2 is going to be 1 because it's a y height of 1. Similarly, cosine of theta corresponds to x. So if I had the cosine of pi over 2, I would be considering the x of this point. So this is the point 0, 1. It's 1 high in the y direction. It is 0 over in the x direction. Okay, and so let's see. Use the definition of the function in the reference quadrant. So he says sine of pi over 2 is equal to y, which is 1, and that's it. So that's how he's justifying the 1. Cosine of 3 pi over 2. Here's 3 pi over 2, right? Cosine corresponds to x, and so he has a mistake here. Cosine of 3 pi over 2. Cosine always corresponds to x. Your x distance right there is not negative 1. Your x distance is 0. And so there's a mistake right there. He should be at 0 at pi over 2 and 3 pi over 2 if it's cosine. And so it is a 0 coming out there. Example 3 is cosecant of pi. Now what's cosecant? Cosecant's the flip of sine. So that's what he has, 1 over y. Now, of pi. Now, if we look at pi, here's pi right here, the blue line that I'm drawing right here. That's the angle pi. If you're on this line and sine corresponds to, and you're looking for a y, right? I'll get away from sine. If we go to cosecant, we got 1 over y. He's absolutely right that the y height is 0, so cosecant then is undefined there. In example 4, he wants the secant of 3 pi. Well, where's 3 pi? Here's 1 pi, 2 pi, 3 pi. So 3 pi is right here. Secant corresponds to 1 over x. He's absolutely right there. The x distance out on that line would be a 1 distance out, but it's in the negative direction, so it would be a negative 1, and that's what he has right here. So this one's done perfectly. 1 over negative 1 is negative 1. So that one's done okay there. Example 5, cosecant of 3 pi over 2. Well, here's 3 pi over 2, or 270 degrees. Cosecant is 1 over y. My y height is a negative 1, because remember, our r is always negative 1 the way he's done it, and we get a nice negative 1 out. In example 6, where's pi? Pi's right here. Cotangent. Cotangent is x over y. So remember, if we think about it as that being the coordinates, oh, he has them there, negative 1, 0, then it's negative 1 over 0 or undefined if it's cotangent. Example 7, 7 pi over 2. So if we go down here and consider the point, right, let's make sure that's where we are. Maybe I'm not quite right there. Yeah, I think I am, right? Here is 1 before that would be 6 pi over 2, which would be 3 pi, and then we're pi over 2. So just like he says, we're 270 degrees or 3 pi over 2. If we're looking at cosine, cosine corresponds to the x. We are 0 out, and we get a 0 out for that one. Sine of a negative 11 pi over 2. So remember, we're going backwards. Be careful here. So the closest one would be negative 10 pi over 2, which would be negative 5 pi, which would be right here. And we're going in the negative direction. So we are ending up right here on this axis, so we're considering the point 0, 1. Sine corresponds to y, and our y coordinate is 1. So these quadrantal angles are pretty easy. They're either 1, negative 1, or 0 or undefined. So let's do a couple more at least. Maybe we'll look at example 9 and then example 11, leaving the other ones for you to read. I hesitate to skip because I found some mistakes, as you've seen. Negative 3 pi. Well, where's negative 3 pi? We know it's right here on this axis. So we're considering this. Secant. Secant's the flip of cosine, so it should be 1 over x. Now cosine, here's a mistake, right? Cosine 1 over x, right? Or it's even here. What's the x coordinate? Let's go find it. Oh, nope, no mistake. It's negative 1. So we get a nice negative 1 out of there, because that's the x coordinate. And then cosecant, in example 10, negative 6 pi would end up right here. All the even pi's are right there. Cosecant is related to, now we got a problem here. Secant and cosecant can't both be 1 over x. So secant is the flip of cosine, so 1 over x is correct there. This is 1 over y, right? And so if I go back to the first pages, let's go look at what his cosecant definition is. And let's make sure we're doing okay. Cosecant definition, absolutely 1 over y. So let's go back to where we were. It should be 1 over y. If we're looking for our y coordinate, it's 0. So this should be 0, and this should be undefined. Glad I didn't skip that one. Feel free, if you ever feel like there's a mistake in the homework, to clarify through email, and I'll clarify for the class. So let's look at these last two that are here, since we've gone this far. So example 11, negative 9 pi over 2. Okay, so where is negative 9 pi over 2? Well, it is going backwards, and it's beyond negative 8 pi over 2. So negative 8 pi over 2 would be right here, right? It'd be going backwards, 2 pi, 2 pi, 4 pi, 6 pi, 8 pi. And then again, 1 more pi over 2. So he's right. We do end up right here on the 270 degree, or 3 pi over 2. So these are our numbers. Secant. Secant's related to cosine, so it's 1 over x. That's correct. My x is 0, so this is undefined. Correct. And tangent. tangent of negative 5 pi, we know where negative 5 pi is. It's right there, all of our odd multiples of pi. And so tangent is y over x. Tangent's just like slope. And so the y coordinate is 0, the x coordinate is negative 1. Divide those and you get a nice 0 out. So play around with those. What you want here is speed and efficiency, because these are small parts of larger problems in your next class. I'm grateful that we went through so many together because there were some mistakes in there. So pay attention to those, but maybe it's good that there were mistakes in there. I am questioning the first mistake that I found, so let me see if I can find that really quick. And come up with that. So maybe it was here, cosine of 3 pi over 2. Cosine corresponds to x. Yeah, our x is 0. So that was correctly identified as a mistake. So take a look at that and let me know if there's questions through email or another way, and I will address those individually and collectively. Thanks so much.